Hi, today in this video we are going to talk about how to apply area model to calculate probability. I will go over a question that's similar to the CornMaze assignment. Make sure you have studied page 1, 2 of probability module. Make sure you watch all the videos in that page. Here are some extra videos that can help you. It is also located in the user link in your course. If you go to your course homepage, scroll all the way down on the right hand side, you will see user links. And under there are some tutorial. I also posted it under the content. If you go to content, okay, videos that can help you should be also listed here under extra resource. However, always check on the tutorial on the right hand side of your course homepage, because some of the videos are not really specific for certain assignment, but it can help you your understanding overall. All right, you can only continue watching this video after you have done page 1 and 2 in the content. Okay. All right, this is our sample questions. Okay, this is the area models, and I'm going to use this area model to draw a tree diagram, draw a maze, calculate the probability of getting a yes, and calculate the probability of getting a no. And also, lastly, we'll do, okay, let's say there's 150 people enter the maze. How many pumpkins do I need to put in a maze so that I have my winner will get enough pumpkins? All right, let's say these 3 models, okay? If there are 3 rows, meaning this maze has 3 paths, 3 main paths, okay? And then if you see a yes, meaning that path lead to a path that you can get a pumpkin. If you see a no, meaning you're not getting a pumpkin. So we are going to draw a tree diagram. The videos in the course showed you how to draw an area model using a maze. And in this case, I'm going to do the opposite. I'm getting the area models. I'm going to draw a tree diagram, and then I'm going to come up with a maze that matched these area models. Okay, and this use some reverse thinking, but it's doable. So let's get started. So you have 3 main paths. So we're going to start 3 main paths. Let's change the color. I'm doing tree diagram. Okay, tree diagram is different than your. Okay, so path A, path B, path C. This is path A, B, and C. So since I have 3 paths here, so meaning the chances, the probability to go into each path is 1/3 because there are 3. Okay. This is to start. Alright, so let's look at path A. Path A, just look at the top rows. You see there's a big section of Y, and then two smaller sections of Y and N, which is yes and no, and then another section of N. But you can see overall there are 2 big separations. 2 big separation meaning after I go into path A, I have 1, 2, 3 big branches. Okay, so I'm going to draw that 3 big branches. 1, 2, 3 big branches. Since I have 3 big branches, the chances of going to each of these branches 1/3, right? Okay, and then the first branch, I'm going to get a yes. Okay, that's my first branch, yes. The second branch, I'm going to get a yes and a no, which is it's going to split again. Getting a yes and a no. So because it's split again, split into two, so the probability is 1/2 because it's And in the third branch, I'm getting a no. So just no here. Okay, there's no more split. All right. Now we're going to work on path B using purple color. Path B, once I go into path B, I can also see there are two big splits, okay? And then for the first branch, you split again, and second branch, you don't split, and the third branch, you split again. So let's draw 3 big splits. 2, 3. Oh, sorry. And each split, because I split into 3, you know the probability is 1/3 in each branch. And in the first branch, right here, I split into 2, and both I will get y. Okay, just a different kind of y. So I'm getting a y, and I'm getting the y. And then what probability is going to go here? It's going to be half, because it's split into 2 in this intersection. And the second branch, right here, I'm getting a no. So just go straight to no, no more split. And the third branch, I'm getting a yes and a no. Okay, a yes and a no. So I split again. Half, half, a yes and a no. Okay, so here we complete our second path. Now we're going to look at the third row, which is the third path. If you go to path C, okay, and you can see there are also 2 big splits, split 1 and split 2, okay, and now you can tell. So since there are 3 splits, I'm just going to draw 3 first. 1, 2, 3, okay, and each of these is going to be 1/3 because it's split into 3. And in the first split right here, I'm getting a yes. The second split right here, I'm getting a no. And the third split, I get another split right here because of this line. So I'm splitting again, getting a yes and a no. And each of these, because it's split into half, is 1/2 and 1/2. Okay, so here's okay, now we're going to draw, using that to draw the maze. Now your maze cannot look exactly like your tree diagram, okay? So if you see the example from the book, okay, if you see the example from the book, okay, each branch, right? Each branch of here, some of the yes, they share one part, okay, one part of pumpkin that they are sharing. It's just they have a different way to get to the same path, okay? So you need to be creative about how you're gonna draw this corn maze. Well, for me, when I come up with these questions, you know, it took me some time to really figure it out. I do my first sketch, I what's it called? I erase this, and then I add some path here because I don't really want to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 station. Because if I'm the maze owner, I have 13 station. I need to have, you know, create 13 out. It's just big and it's not fun. Okay, so your maze will be add some creativity to it, add some shortcut to this one, and cut through different paths to make it to your maze. Okay, so this is how we'll start. I just show you how I start thinking, my thought process, and then I'm going to show you my final result, because it doesn't take just 1 minute to come up with a maze. You know, it takes some time to figure it out. Okay, so if you cannot get the answer right away, meaning you are abnormal. Okay, so let's see. I'm looking at my first row. I know I have three big paths, so okay, let me just start with 3. 1. Okay. Then I got second path, got third path. Alright, let's start with the first one. First, let's say I have a part of the first one is gonna take me to a yes, and then a no, and then one of them is gonna split. So let me have a yes here and a no here. So let's say the first part's easy, just bring me to a yes right away. Okay, that's done. Okay, so assuming I don't want anything else to go between here, but something else might cut to here. Let's see, I want to make this yes here also go into here. So my second path will, after I split with my first one, see this one will split into 3. So I'm going to, let's see. I'm just sketching. I want to see whether this will actually bring me to the result that I want to. So I want to design something that will split here. Okay, and then one of them will, yes will go here, and then one will go to the no. Okay, one will go to the no part right here. So the second split yes and go to no. And then the third path, when they split, so in here, because there are 3 split, so here I need to erase it. Now see, I'm just sketching. Like when I draw, it just takes me some time to figure out what exactly is gonna come out, like exactly how I want it, right? So this is my first yes. The second one is going to go to yes, and then let's see, it's going to do this to no. Okay, my third one's going to go straight to no. I'm still working on path A, okay? This is path A. I'm still working on path A. They split into 3 big paths. Okay, let's say it's actually taking a shortcut like this, you know. Yeah. Into here. This is, but later on, I might want to put some of the no here into this part too. So I might have to like erase some of these so that, you know, I added some short path from here. So this is how the thought process, okay? That's how you create a maze that is give you a good grade, okay? Because I'm going to show you what my maze is. This is my final result after many trials, okay? And the next video, we're going to talk about whether this maze actually matches our, what's it called, a table.